Hey everyone, welcome to the start of a new series. Now, from the Year 10 content that I'm working through here, we are going to be looking at quadratic expressions and quadratic equations. So similar to a lot of the stuff we looked at in Year 9, but we are adding a couple of new concepts here, and one of which we're going to be talking about today. And this is the idea of what we call factorizing by completing the square. And for this particular video, I'm just going to give you a nice little introduction into what this actually means and why we do the actual process. And we're going to show this through some geometrical means. Because here we're looking at a square. We first encountered squares way back in like primary school geometry. So we want to revisit some geometry ideas to give you a visual idea of what this stuff actually means. Now, as with a lot of other series, most of the things from this, like factorizing monic, quadratic trinomials, non-monic, things like that, we covered in last year's course. So I'm only looking at the new things here, and we will also have a lot of revision of those previous concepts too, but I just want to get straight into it with something brand new. Now, what we're doing here, we are practicing this method and learning about this thing called completing the square. And what we're doing for these first two introductory examples in this video that I'm doing now just on understanding the process, we want to find a number to be added to this quadratic expression, x squared plus 2x, in order to complete a square. And then we want to factorize the resulting perfect square that we get. And we'll talk about why it's a perfect square as well later. But here, I don't really know how to do something like this. I don't really know what I should add over here in order to complete this square. So I want to try some kind of geometric approach here. So in doing this, I'm looking at two particular areas. So I have this square here, which has an area of x squared. So that's when we have units of x by x. Because we remember when we multiply two dimensions, we get an area. So we have x squared plus 2x. Now we can think of this as 2 along this dimension, and then x along this dimension here. And we want to say, okay, well, how are we going to make a square out of this in the first place? And it's not immediately obvious what we do, but what is going to be a resulting thing that's going to happen when we do this is we want to somehow piece together these two things to make an even bigger new sort of square. And we'll talk about how we actually do that in just a second. Now, what do we notice? Well, we notice that these two shapes have something in common. Now, one is a rectangle, one's a square, but we notice that these two dimensions line up. So x with x lines up here. So if I can find some way to maybe paste this thing to here, for example, and this guy here down to, let's do that in the same color, down to here, we may get a little bit closer to what we want to find here. Because remember, with this question, we want to add something to this in order to factorize it. So why don't I do something very sneaky here? Why don't I imagine cutting this particular shape perfectly in half so that I get two new little rectangles here. So if I cut this in half, my dimensions are going to change. I'm going to get something that's still a length here of x, but my area over here is going to be 1. So I have I've essentially halved my 2x into two smaller rectangles. And why don't I try to copy and paste these and attach them somewhere to this one over here? Now what I'm going to do is I'm going to draw out two new shapes that look like this. So, and I'm going to stick them onto here. So one of them, in doing this addition, I'm going to add one of them to here. Let's make that a bit nicer. Okay, so I have my X area here, and I have my dimension of 1 by X. And I'm going to have my other one here, and I'm going to rotate it so that X sticks perfectly over here. So I still have my dimension of X here by 1 over here. Let's do 1 over here. Okay, that's good. And this is going to be my thing here. So this is still showing an area of x squared plus 2x. I have my x squared here, and I'm adding two things of area x to it. And you can probably see this looks sort of like an incomplete square. What I need is something to fit into this thing. And that is going to give me a square. Because, and the reason it's going to give me a square is I have a total length here of x plus 1. Because I can see here is x, and I'm adding 1 to that. And this dimension here is also x plus 1, my x here and my 1 here. So this is clearly a square because the two dimensions are equal, and we just want to find out, well, what is the area of this guy in here? So we want to consult my diagram. So I can see that I have a length of 1 for this dimension and a length of 1 for this dimension. So I'm going to have a dimension of 1 times 1, which just gives me 1. So what I'm actually adding to my x squared plus 2x to make a square and then complete it is I'm adding 1 to that. I have x squared plus 2x plus 1. And once I've added this, I just need to factorize this now. And some of you, if you've clued onto this already, can probably already see what my total thing is going to be when I factorize this. That's just going to be one dimension by the other. But let's just double check this with PSF, which we learnt when we factorized monic trinomials. I want two factors where the product is 1 and the sum is 2. So my factors are going to be 1 and 1 because 1 times 1 gives me 1, 1 plus 1 gives me 2. So my quadratic is going to factorize to x plus 1. I'm doing this the quick way because we've already covered this before in last year's content, multiplied by x plus 1. In other words, whenever I multiply one thing by itself, I can write that as that expression squared. And let's just confirm this on my actual diagram, because we can see here that, as I mentioned before, I have a square with one total dimension here of x plus 1, because I have x and I have 1 here, and 1 is also this particular dimension here. And I also have from here to here x from this guy here and 1, because this is another square down here. So I have two dimensions of 1. So using this area idea, in the area of this square, because we looked at an area of x squared plus 2x, the area of this total square is going to be these two dimensions multiplying by each other, x plus 1 by x plus 1. And that gives us the same thing when we do our PSF of x plus 1 all squared. Now, that could have just been a coincidence. So let's have another question. Let's have a go at another question and see what actually happened, the actual process we did, and like all things in maths, we're going to observe these patterns and try to apply a quicker way of doing this once we can kind of see a pattern. Now here I have x squared plus 10x, and once again I want to see what can I add to this to create a perfect square. And I'm going to use this area analogy again. I'm going to have one square here of x squared, and I'm doing this a little bit smaller because I'm going to have a really long dimension here of an area of 10x, and I want to be adding these two together. So we're using the same geometric approach here. Now I have a little square here of dimensions x by x, and I have another one here with dimensions x here because that lines up with this. These are the same lengths, x by 10. Now I'm going to do a similar thing because I can't see how this is a square right off the bat. So why don't I do some cutting and pasting to break this guy here into two bits and paste those to these two edges and then make a bigger square out of this. So what I'm going to do is I'm going to cut this in half. And if I cut this area in half, well, this length here of 10 is going to get halved to give me 5. And I get a length of 5 here as well. And my x remains the same. So I have an area here of 5x and 5x. And I'm going to cut and paste these things to my square over here. All right, so let's redraw these. See what we get. Now, I have, let's bring this over, paste it in. It's my best attempt with this software to do something of this kind. But I'm going to paste in my 5x, and I'm going to cut and paste in my other 5x here. And remembering my dimensions here are still x because this fit perfectly onto here. So my x dimension is going to be the same as this x dimension on my other square. And I have 5 here because what multiplies by x to give me an area of 5x, it has to be 5. So here I also have 5 by x. And I want to see, well, what area is going to make up this remaining bit here in order to give me a perfect square. Something that has equal dimensions up here by along here. Okay, let's see what information my question's giving me. Well, I can see that I have a dimension of 5 by another dimension of 5. So I'm going to have a square within here of 5 by 5. This is 5, this is 5, giving me 25 within here. So the thing I needed to add to x squared plus 10x in order to make this a perfect square was the number 25. And we'll see why this is in a second. Now, once again, we're going to just see what this factorizes to using PSF, and then we're going to show this visually as well. Now, I want a product of 25 and I want a sum of 10. And what number multiplies, or what numbers multiply to give me 25 and add to give me 10? That's going to be 5 and 5. So I'm left with x plus 5 and then x plus 5 as well here, which gives me x plus 5 all squared. Now let's just check that with the square that I have here, and considering those areas, well, I have a dimension along here of x plus 5 multiplied by my dimension here, or at the top, doesn't matter, of a distance of x plus 5. So whether I do it geometrically or once I get to this stage I do my PSF, I get to the same type of expression. Now let's look and see if there are any commonalities with what we did. Now, my thing factorise at the end to give me a perfect square. Remember, these perfect square factorizations were when we had two of the same factors here. So that when we factorize it, it just gives me the same thing multiplied by itself. So here we got a perfect square. Up here, we also got a perfect square. Here. And we saw that by having two equal factors here. Now, what did we do every single time when we did this type of question? Well, up here, when we found the two smaller, when we broke this up into two smaller rectangles, we halved my 2x. So, we halved this. And that broke this up into x plus x. Down here, we halved my 10x to get 5x and 5x. And then that allowed us to make the perfect square. So applying this to these quadratics, we're coming up with a general formula here, which we're going to build on in the next few videos where we look at some proper questions. So far, we've observed that when we had something in the form of x squared plus, now if we look at this with the general formula of any quadratics, where we had ax squared plus bx, where a is just 1, because both of these were monic. And if this is new, please consider viewing some of the previous videos where our general form of quadratics are ax plus bx plus c. But when given something like this and finding what c to actually add on, we did a process of halving the b. So we took the coefficient of x and we halved it. Our 10 in the previous example got halved to 5. Our 2 in the first example got halved to 1. So this ends up condensing down into x squared plus bx. And what we added on the end here was my half of this, my half of 10, which is 5, and we squared that to get the area of the square that completes this, that makes our big square. Remember, this is called completing the square. So we're using what we have to complete, to finalize a really big square here. So we took my b and we divided it by 2, and then we squared it. And then that condensed to whatever we had here of x plus, and we had b on 2, all squared. And this is my general formula so far. We've applied our observations to come up with a generalized idea. Now let's just double check that this is confirmed in our other questions. We have x, and our things always ended up being the number adding to x in here was half of this coefficient, and then we squared the entire thing. Now over here, half of my coefficient of 10 is 5, and lo and behold, we got this thing down here. x plus, when this factorized, we've got x plus half of 10, which is 5, all squared. Up the top here, we looked at, if we were to halve this coefficient of x, my b, half of 2 gives me 1. And once again, we had x plus whatever the half of b was, all squared. So this is just a long form short video showing you some hands-on examples using geometry in which we can come up with a general pattern for numbers that we add to my quadratic in order to complete a square. In order to take my sections here, I'm going to highlight them in a second, take my sections here and these ones here, and thinking, what do I add to that in order to make a perfect square, an even bigger square? Now, all this writing looks really intimidating, and I understand, I did this once in school as well, but we are looking at this process that breaks these things down into smaller bits that we can work through. And this is how we can think about starting to factorize by completing the square. And in the next video, we're going to apply this to a lot of examples. But I just wanted to give you a kind of long form, slow video to hopefully give you some of the intuition as to how these things work in the first place. But thank you so much for watching, and I'll see you in the next one.